Hey everyone, welcome back to my Calculus 2 series. In today's lesson, we're going to be talking about another type of series called the alternating series. So here is the definition for what an alternating series is, and it's basically a series whose terms alternate between positive and negative values or terms. Now, if we look at a series like this, for example, where we go from n equals 1 to infinity of minus 1 to the power of n, times n over n plus 1. Well, as we can see, if we start with n equals 1, let's look at what it'll be. So first of all, we'll have a negative sign because minus 1 to the n, well, that will be a negative 1. So it'll be minus, and then over here on the numerator, it'll be 1, and on the denominator, it'll be 2. So we'll have minus 1/2. Now on to the next term when n is equal to 2. This value right here becomes just 1 because anything raised to an even exponent would mean that we sort of get rid of that negative because, well, we multiply it an even amount of times, meaning the negative kind of disappears. So this right here, this term is just going to be a positive 1 in this case. And then since n is 2, well, it'll be 2 over 3. Now if we go on and we take a look at when n is equal to 3, well, now this term right here, let me erase these. This term right here now becomes negative again because, well, the exponent is now going to be odd, meaning we are going to keep this negative sign. And then if n is equal to 3, then this is just going to be minus 3 over 4. And again, when n equals 4, now it'll be a positive sign because, well, minus 1 is raised to a positive, to an even exponent, meaning that negative sign will disappear. So now we'll have plus 4 over 5. So now you can kind of see how these terms sort of alternate. So we have a negative term here, and then we have a negative term here. It, in a sense, skip over terms. And this is what an alternating series is. It's basically just a series whose terms kind of alternate in between these negative and positive values. In order for us to determine whether an alternating series is convergent or divergent, we have the alternating series test. And we basically say if the alternating series, and then it's given by this, satisfies these two conditions. And before I get to those conditions, let's take a look at this series. So we have this minus 1 to the power of n minus 1, right? Which is, in a sense, like that's the term that tells us whether we're going to have a negative or a positive value for that term. So you can often see minus 1 to the power of n minus 1, or like in the example, you can just see minus 1 to the n. Basically, if you subtract 1, that means you'll kind of start later. In this example, as we can see, we started off with a negative term right here. But if we were to put n minus 1, well, then it'd be the opposite. That means like these terms would be negative instead. So the negative terms will start later. And then this b of n, well, b of n is whatever else that's kind of in that series. So if we go back again to this example, this was b of n. So it's essentially the other kind of, I want to say, term that doesn't determine what the sign is. It just determines like what the actual value is of that term. Now that that's out of the way, we can see that the first condition is that b of n plus 1, meaning if you want to think about it, the next value of b of n, of just this term right here, should be less than or equal to b of n, meaning the current term that we're on. So, and that is for all n. And then the second condition is that the limit of this b of n is going to equal to 0. In that case, well, we can say that the series is convergent. Now let's look at how we can apply this alternating series test in two examples. So let's say we're given this series and we're asked to find out whether it is convergent or divergent. Firstly, one thing to note is that obviously this right here, the numerator, is the term that determines whether we have a negative or a positive sign. So we can kind of rewrite this. If we want to clearly see what b of n is, well, then we can rewrite this as saying minus 1 to the power of n minus 1 times 1 over n. And quickly you can notice that this right here is the harmonic series. So if you remember, this is the harmonic series. However, what we have here, this minus 1 times 1 over n, well, this is the alternating harmonic series. And if you remember from previous lessons, we learned that the harmonic series is divergent. So now let's analyze the alternating harmonic series. And again, this could be an n minus 1, this could be just an n, whatever value it is, but the main point is that it is alternating. That minus 1 kind of tells us that the series is going to be alternating. So let's apply the alternating series test. Well, condition 1 is that the next term, so that b of n plus 1, should be less than or equal to b of n. And as we can see, this is going to be b of n here. So I'll label that b of n is going to be 1 over n, because this value right here determines whether we have a negative or a positive sign. And then this term kind of determines the value of the actual term. So now let's grab a look at b of n plus 1. So bn plus 1 should equal to 1 over n plus 1, and then b of n should equal to 1 over n. And we can clearly see that b of n plus 1 will be less than 1 over n. And so because this is true, well, condition 1 is met. Now on to condition 2. So condition 2 asks us to take the limit of b of n as n approaches infinity, and we want to ensure that it is 0. So let's go ahead and do that. Well, the limit as n approaches infinity of b of n, well, b of n is just 1 over n, and this is a pretty standard limit, and we know it's equal to 0. Therefore, we can conclude that that series, the alternating harmonic series, is convergent. So moving on to example 2, let's look at this series right here and determine whether it is convergent or divergent. So again, we want to rewrite this series to clearly see what b of n is. And so it's going to span from n equals 1 to infinity. We're going to have minus 1 to the power of n. And then b of n, well, that's going to be 3 over 4n minus 1. So b of n is clearly equal to 3n over 4n minus 1. We could go ahead and determine that first condition, but clearly it's pretty obvious that if we were to take the limit of b of n as n approached infinity, well, that would clearly not equal to 0. And it's pretty obvious because, well, we can go ahead and follow through with this limit right here, and you can clearly see that it's going to approach 3 over 4, and that's because, well, the dominant term here is 3, and the dominant term here is 4, and so once we factor out n, you'll see that we'll be left with 3 over 4, but if you don't believe me, here's the solution. So there's the solution, and as you can see, the limit is just going to equal to 3 over 4. Therefore, we don't even need to check condition number 1. A lot of the times it's just easier to check this limit before we do anything else. So in this case, we can clearly see that condition 2 is not met. Therefore, this series is going to be divergent. So that's it for this quick little lesson on a different type of series called the alternating series. Hopefully you guys enjoyed the video. If the video has helped you out at all, please like and comment as to what I helped you out with. Like usual, if you are new to the channel, please like, comment, and subscribe. It's greatly appreciated. And yeah, I will catch you guys in another video.